Now we're going to think about material properties, and we're going to largely be considering what we're going to call insulators and conductors. So we're going to think about how our charge, so far plastic type charge and glass type charge, seems to move or not based on the material. So if I have a metal sphere, and here we're talking about an isolated metal sphere, so it's not a metal sphere I'm holding in my hand, but it's going to be a metal sphere, say, on a wooden base, which we haven't yet justified why the wood isolates it, but it does. And if I touch a charged plastic rod to my metal sphere, the metal sphere then acquires plastic charge. How do I know that? Well, the metal sphere would attract little bits of paper, meaning that it is charged. And if I brought a hanging plastic rod near the metal sphere, it would repel it. So this acts as if it is itself a charged plastic rod. So touch it seems to transfer charge. Now then, a second thing we can do is going to be called discharging, so somehow neutralizing the charge. A rod that had been charged, we can basically drag our finger along it as if we're wiping the charge off, and no longer will it pick up the little bits of paper. And we will explain in a microscopic detail what's actually happening here, but we see that charge is somehow a property that can be removed. We can return our object back to its neutral state by touching it. And not just touching it with anything, we do actually mean touching it with our finger in this case. Touching it, for instance, to a pen cap might not have the same effect. Now we get a little more complicated. I have my metal sphere, which we saw before that touching with my charged plastic rod seems to transfer plastic charge. I can then connect a second metal sphere via a metal rod. So I'm only touching the charged plastic rod to this metal sphere. However, if I then disassemble the whole system so that this metal sphere is by itself, I would see that this metal sphere attracts little pieces of paper and that this metal sphere repels a charged plastic rod. So we know that touching the rod to this metal sphere would transfer plastic charge, and seemingly this metal rod then allows it to move through and get to this sphere as well. So we're going to call that effect conduction. It's going to be very important for almost the rest of the entire class, and this is a property of metal. If we do this experiment, in fact, again, by using a plastic rod here, not a charged plastic rod, just a normal plastic rod, we again charge the plastic rod by rubbing it with wool, touch it to the metal sphere. This metal sphere becomes charged. It again repels our rods, attracts the paper, but this one does not. The plastic rod does not transfer the property of being charged to the second sphere the way that the metal rod did. So there's fundamentally a difference in how the metal rod allows these two objects to interact in terms of being charged, and how the plastic rod allows them to interact, or in this case, does not allow them to interact. It's as if the plastic wasn't there. So this property that the plastic has, which we'll call being an insulator, air does as well. So that's one way to think about this. If nothing was in contact between these two, you wouldn't expect the charge property to just jump from one to the other, and the plastic rod doesn't allow it to. But the metal did allow the charge property to transfer through. So these are now then two additional aspects of our charge model. We know that there are two types of materials, which we're going to call conductors and insulators, and we're going to say that conductors allow charge to move. We again haven't defined at a microscopic property what this is, we're about to, and insulators don't allow charge to move. Now, one thing that's important to understand is that both of these materials can actually be charged, right? Our plastic rod, by definition, is an insulator, and we have charged it. So this isn't about having charge or being charged. This is about how charge can or cannot move. So there's a few different properties to think about here that are different, so please be careful about that. And lastly, we see that charge can be transferred simply by contact. We can seemingly remove it by touching the object with our hand, and if we take a charged object and touch it against another one, that seems to leave some charge behind. So this is now what we know from our kind of simple experiments, we now are going to jump ahead and define what's happening on a microscopic scale. But please understand what these basic experiments are telling us, since if you only rely on what you think you already know about, for instance, atoms and electrons at a microscopic level, you're probably going to misunderstand some of the physics phenomena we're going to be talking about. So please review all of these experiments before plunging ahead into the microscopic model.